Building a CLI agent in Go. All right, so in this video, we will use Golang to build a CLI agent in our terminal that we will run it using a large language model. We will ask it some queries and it will answer our queries. So let's get started. Before we start, we need to understand what an AI agent is, obviously, so we can build one. So how does it work? What are the main components of an AI agent? Now, we all know LLM, we're 2025, 2026. We all know what an LLM is. It's a large language model, things like ChatGPT, things like Claude Sonnet, things like Google Gemini, all of these things, all of those models are large language models trained by or on a set of data in order to do some compute and actually respond to human language with a human language. So this is basically what's a large language model. Now, an AI agent have a large language model, but it's not just a large language model, all right? It's a set of components that will create the AI agent. And those components are mainly three, okay? The first one is obviously the model, the brain of the LLM, of the agent, which is the LLM. And yes, there are different types of brains with different capabilities and different speeds of response and all of that. This is the main component, which is the model or the LLM. All right. The second component is the context. The context is the information that the LLM has in order to solve your query. And this information can include the query itself, but also any other related information in order for the LLM to solve that query. The third component is the tools. And the tools are also very important component in order to build an AI agent. And tools are basically functions that we call and give the answer of this function to the LLM in order to solve a certain query. So let's say you want to know the weather in a certain city. Now, the LLM by itself does not have this information because it's not going to be the actual information of the weather that you want to retrieve. So in order to get the actual information of the weather and for example, build an agent that tells you what to wear, what you can do is call a function, right, that gives you the weather in a certain area or in a certain city, and then you take that information of the weather from the API call, you give it to the LLM, and then the LLM will decide based on this information what clothes you want to wear, and it will give you that answer. So this is basically a function call or a tool call. And those concepts are mainly the components that actually builds an AI agent. Now, there are certain components and strategies within each of these main three components, but mainly those are the three components that you need to know in order to understand what an agent is, okay? In this video, we won't cover all of the components. We'll cover only the first component, which is the main component, the model or the large language model, the LLM behind our agent. So we will build a CLI agent using a model, and we will make it answer our request that we write in our terminal, okay? If you guys give 100 likes on this video, we'll make other tutorials covering the context and other components of an AI agent. To follow along with this video, you need some prerequisites. So Golang, obviously, we will use Golang to write our CLI agent. So you need Golang installed and running on your computer. Running meaning you can run it. You can run some Golang programs, okay? Second component is an IDE, and this is basically something you can write the code in, because we're going to write code, so we're not vibe coders. Actually, we will write some code, so you need some tool to write the code in. I will use Vim personally, but you can use whatever IDE you want, be that VS Code, Windsurf, whatever. The third prerequisite is actually API keys, and mainly it's one API key. We will use OpenRouter to power our LLM. So basically, an LLM is hosted on another server, and we can use that via an API calls in order to get the response. Now, you can use also LLMs that are running locally via Ollama, but in this video, we will use OpenRouter for convenience and to show you that you can actually use any model from just one API key, which is very good. And the fourth component is support, and this one is for me. I need from you. So if you like this video, drop a like button or smash the like button. Yeah, consider subscribing for more videos specifically about AI agents, bot development, automation, all of this stuff that I will be covering in this channel. All right, so let's get our hands dirty with code. Yep, we will do that. All right, so to start building our CLI agent, we will create a directory for our project. So mkdir, we create a directory, and we call it whatever we want. I'm gonna call it build AI agent demo, just like that, okay? Then we change our directory or our current location to the new directory, which is build AI agent demo. And here we're just gonna simply initialize a Go module, a Go program. So to do that, we go ahead and write Go init and give it the name of the module or of this package or of this program. So build AI agent demo, boom, just like that. Go mod init, it's actually Go mod init, simple mistake, don't judge me, AI agent demo, just like that. All right, now that we have our Go mod files like this, go.mod, we are ready to go. All right, so to start, we need to provide the OpenRouter API key. And I'm gonna show you how do you get the key, how to create it on the screen. And then after you create the key, you copy it and you come here, you open up your editor in the .env file inside our root directory. And here you just write, and then you put the key that you just copied right here, your key here, right? After you've done that, you quit and save, of course. So what I'm going to do, I'm actually going to cp or copy the .env file that I already created for the other demo to use it here. It's the same thing, but you just use your own API key. So here I'm going to go ahead and say just like that. Now, after you have your .env variable, we can start now writing our code. Now I prefer using tmux so that I have multiple windows. So I'm going to go ahead and write tmux new session. You can install tmux. It's a tool that allows you to have multiple sessions and multiple windows and panels or panes in the same terminal window, so that I can use the CLI and then go back to my editor without having to close it and open it every time. So tmux new session, and then we give it a name. I'm going to call this demo. And now, as you can see, we have this kind of lower bar, which is indicating that we're using tmux. And with tmux, I can open up a new pane just like that. And yeah, I probably forgot to put the actual keycast for you guys. So I'm going to do it right here so that you can see whatever keys I actually press. I will put it in the top corner just like that. Okay, we will run the program. So to do that, we will first export our variables, like environment variables, and I do export the environment variables via this command. Now there are multiple ways of doing it. You can even use a library to read it directly in your application, in your Go application, but I prefer using this. I just simply export it as I exported any environment variable. So you can do export $, you open up parentheses, and then you say cat.env, and then you pipe that to the X arc just like that. You press enter, and now you have your OpenRouter key available in this terminal, so you can run your program. Going back to our code editor, should open code editor here, and we write our first file, which is going to be the main.go file. It's the only file that we will need. We write package main, and then we write the function main, that this is the function that is the entry of our application. And here we just want to go ahead and check if we have the actual API key. Now we need two things. We need the OpenRouter URL, like the endpoint that you will call in order for you to use OpenRouter API, and we need the API key. Let's check the API key, for example, for OpenRouter, and we can say API key, you read it from os.getEnv. So we'll use the environment variable that we just defined as OpenRouter API key, right? And we will read it, and then we will check. So if API key does not equal empty string, or if it equals empty string, we will have an error. So we're going to go ahead and say maybe log fatal that the environment variable is not there. So API key is required, just like that. And now if we go back to our terminal, we already exported. Maybe we shouldn't have done that, but I will show you how you can check if it's not there. So we can close this pane, for example. We open up a new pane, and now we haven't exported our variable. So when we run the program, it will show us an error. So if we go ahead and say go run dot or main.go, we can see that there is an error. API key is required. After we run the command of exporting the env variables, export cat.env, pipe that to xargs, just like that, we press enter. And now if we run the program again, boom, we don't have that error. It just runs perfectly, which means we have the OpenRouter API key now read in our program. The next thing we need is the URL that we will call upon the endpoint from OpenRouter. And the URL, I'm just going to copy it and paste it. So bear with me. So here we have the URL for the OpenRouter endpoint, and it's at openrouter.ai/API/v1. You can find the endpoint on the OpenRouter site itself. Okay. Now that we have the API key and the URL, we can use the OpenAI SDK, which is an SDK that is compatible with OpenRouter. So we can use whatever model. We don't have to use models from OpenAI. We can use whatever models from Gemini, from whatever model like Grok, Sonnet, any other model via OpenRouter, but it's compatible with the OpenAI SDK, which we will use to make our life easier using or building our agent. So what we need is to create a client that we will use this client to call upon and actually use chat completions or request some chats or interact with the API. And to create this client, we will use OpenAI. This is specific OpenAI SDK. And before we actually write anything, let's actually just install this OpenAI SDK so that we have auto-completion. So to do that, we go back to our terminal, and here we go get, just like that. So go get, and then github.com/openai/openai flag go, and then the version 2. We press enter, and we install this library. Okay, after we're done installing this library, we go back to our code, and now we can use OpenAI. So we can create our client that will come from OpenAI, which is the library we just installed, .new client. And we will use a few things here. So new client, we will use the base URL from the URL here. So we can say option, we call the option, which is another like a package from the OpenAI. So like this, option.with base URL, just like that. And we give it the URL. And then we add option, another option with API key, and we give it the API key. So this way, this client will use this endpoint instead of OpenAI endpoint, and it will use this API key for the API key. Okay. All right. And now we can use the client to add some completion to our chat and actually use the AI LLM. So to do that, we will need to create a messages array. Messages arrays is simply an array of this type. So OpenAI.message param union, all right, message content param union, or actually it's actually chat completion. So chat completion message param union. This is the type that we will use with the actual method that we will call upon right next. So we create a messages array that is the type of a slice of OpenAI chat completion message param union. I know this type is too long, but that's what is defined in the SDK, so it's not my fault. Okay. The second thing is the model. So we need to actually find a key of the model that we will use, and obviously I'm going to show you how do you do that. You just basically go to the OpenRouter page and search for any free models by just writing free, and then you copy the first one that you can get. And going back to our code, what we will do is just define a model, which will be the string of the key of this model or the ID of this model. Okay. Now that we have a model and we have messages, we now can call the chat completion. To do that, we will obviously append our query. So to do that, we go ahead and write messages. We append a new message to the messages array, and this message will be our query. So our question to test the chat completion. And our question will be OpenAI.user message, and we write whatever message here. So how many hours in strawberry, or maybe something that the LLM can give us a better answer. So for example, what model are you, right? Just like that. Now we have the messages array. We have the messages array with our message, our query. Now we can go ahead and use the chat completion. And to do that, we'll go and call client.chat.completions.new. So we start new completion. We obviously need the context. So I'm going to go ahead and define the context right here before the messages. And the context could be any context that you have, like with timeout and stuff like that. So you can time out the request. The context is useful to do other things, but for now we're just going to use a placeholder context like this context.background. In a real protection application or environment, you would use the context with timeouts, and you have timeout specified so that you can time out the request and not really actually make the request take too long, right? So now that we have the context and the model, we can go ahead and use this new method, and we can see that this new method will take context, it will take the params, and any other options. So we need to create the params options or the params object, and the params object will be coming from openai dot, and we will use the type chat completion new params, just like that. We open up these curly brackets to define the parameters, and we will use model. So model will equal to the model key that we just defined, and then messages will equal to the messages array that we defined right here. And then in our chat completion.new, we will just define the context, so ctx, and then the parameters just like that. Now this method will return us response and error. So we will define these. So response and error will come from client.chat.completions.new, and we will check for error. So if error does not equal nil, we will go ahead and log fatal with that error, and then we will log the response content. And the response content, we find it at, so again, I'm going to use fmt printf, or just print, and the actual content of the response, we will find it at response.choices, and then the first choice. Now you can configure the LLM to give you multiple choices, but for most applications, it's just going to be one choices at the first index, right, like that. And then we access the message and then the content of that message. All right. So now our application is basically send a request, a chat completion request to this LLM with this query. What model are you? And we'll print the response. So let's go ahead and check this out, or check our program. We go and run dot, and boom, we should have an answer any moment right now. Yes, just like that. So it says here, I'm gonna just put this one right here. As you can see, the response of the LLM is, I'm Grok, I'm a large language model by XAI, inspired by whatever. Okay, so this means that we actually correctly called upon the API and got an answer. So this is the first version of our program, and you can find all those versions in the GitHub link that I'm going to provide on the blog post of this tutorial on my portfolio. So check out the portfolio, go to the blog post, you can find the links of this GitHub repository that I have all the versions in there. Okay, so the next version, we will go ahead and create a loop that we will then take the standard input of the user and use it as the input for the request. So let's just do that next. All right, so to create the loop, the CLI loop that we will then scan our input and send it to the LLM, we will define a new variable. We will call this variable scanner. So here we're going to go ahead and say scanner will be coming from buffio.newScanner, and then we will give it the standard input as the input for this scanner. Okay, so standard input, just like that from OS. Okay, so after that we will open up a for loop. Basically, this is an infinite loop. You just write for, and then you open up curly brackets, you get the infinite loop just like that. Here inside the infinite loop, we will write a print statement. So fmt.print, we just print like what the key that indicates us that we need some user input, just like that. So for example, you can use this arrow. And then we're going to go ahead and check if there is any scanning error. So if there is no scan, so if scanner.scan does not exist, we'll go ahead and break the loop. That just means that there is something wrong with the scanner. We need to check for this in order to make sure that it works, okay? So the second thing is to define the user input, and the user input will be coming from strings.trim space. So we will trim any space so that we have the actual input without any extra characters. So trim space, where is this trim space method? Just like that. And then here we will define the text that comes from the user, which will be from scanner.text. What's wrong with my autocompleter? Completer. Okay, cool. So now that we have our inputs, we can then check for the input. We can also define our commands here. For example, if the input does not equal or equals to nothing, then we're just gonna continue. Basically, we just ignore that request. If the input will equal, for example, to the word clear, we will clear the terminal. And to clear the terminal, there is like a certain ASCII characters you print in the terminal to clear it. I'm gonna just copy it and print it here. Just like that, UFMT print this kind of characters and it will reset the terminal or clear the terminal for you. And make sure to continue after that so that you start the loop again from this character or from this line. Okay, cool. Now we can also check if the input, for example, is exit, so that we exit the program and we basically break the loop. We can also FMT print here like a statement, for example, like goodbye or whatever, right? You can do that. All of these are just gimmicks, to be honest with you. The real deal is coming right here. So after we have the input, use that input or append it to the parameters that we just defined right here. So these parameters that we will use in order to call the chat completion, we will edit the messages like params.messages and append the user input to it. So we'll remove this method that will just like hard coded this question. We will remove that. And then in our loop, after we did our checks, here what we can do is to append the new input to the messages array. So for params.messages will basically equal, and you have like a chat completion method here in the LSP. So we can see that params.messages will equal to append param.messages, and then you append whatever message here, and using openai.userMessage, we will then append the input of the user. Now that the parameters updated with the new message, we can then call the same chat completion method right here. We copy that, paste it right here basically, and we format. Now we have the messages appended from the user. We can now check that the actual LLM is working. And to do that, we go back to our terminal, we clear the terminal, and now we run the program again. So go run dot and then wait for the program to run. We now have a simple arrow just like that, indicating that we need to input something. So for example, if I say hello, I will press enter and this will send it to the Grok AI or Grok or the API that for the LLM, and the LLM would be providing us with an answer. For example, how can I help you? I would say, for example, what model are you? And it will answer from the API, and it actually correctly said I'm Grok, so it understands what model it is. Is it? We can also use, for example, how many R's in strawberry? I like this request because it shows like how smart the model is, but maybe it's outdated because the new models that actually all of them kind of answer this query right. So hello, I'm Grok. I'm built by AI. I'm designed to be helpful. And then as for strawberry, there are 3 R's in it. So as you can see, what happened here is that it understands the first it read the first and the second and the third message because we appended them to the params, as you can see here, but we didn't append the answer of the LLM, so that the LLM doesn't understand that it already answered those queries, so it answers them in one answer, if that makes sense. Like it answers all of the other queries in one sentence. So to solve this problem, we need to append the answer of the LLM to the params messages. Okay, so to do that, We can, for example, say the output, we call it the output of the LLM, will come from response.choices in the first choice, index 0, and then we access the message and then the content. So this is basically the output of the response for our query from the LLM, and we can print it here just like that, and then we can go ahead and append it to the params messages so that in the other queries or the next queries the LLM understand that it already answered those. And we can go ahead and go params.messages equals just like that. So, and we append the openai.assistant message, and we append the output of the that we got from the LLM. Let's go ahead and rerun the program and see if that is true. So go run dot to make sure that the LLM has the history and it has access to it and it understands what we said in the previous messages. We're going to go ahead and write a question for our query. So for example, we're going to say, tell me a joke. And the LLM should understand this query, answers this query. Why don't scientists trust atoms? Because they make up everything. So this is like the joke. It's very bad joke, to be honest with you, but okay. Now we have those messages in our messages array, so the LLM understands we're talking about jokes. So if I say about Elon Musk, for example, it will just give me a joke about that. So for example, why did Elon Musk name his son X? Blah, blah, blah. So it understands from the conversation that we're talking about jokes. You can just say about iPhone, and it will just it understands that it needs to give you a joke about the iPhone. That means it's successfully reading our messages, and it has successfully access to the history of our chat. So now the model is a little bit smarter, understands the previous messages. Okay, cool. The next version, we would go ahead and check for the message length so that we don't have longer messages or we don't run into context overflow. Now you can do this in many ways. You can check for the response size, like how many characters or how many words, and like limit the messages to a certain word count or whatever. But I'm gonna do it in a very simple way, that is the checking how many messages we have. So in the next version, we're gonna check how many messages we have. We're going to do something if we use a lot of messages. We're going to clean up the chat, and then we're going to use some colors to give our CLI a bit of better look. So let's do that. All right, so next we want to limit the context, meaning that we want to limit how many messages we send to the LLM to just prevent the LLM from having hallucination or context overflow, or taxing us a lot based on how many tokens we send to the LLM, because the LLM is priced on how many tokens output and input you send to it. So the context window management is very important. So that's why I'm gonna add some simple check for the context window. And to do this check is just we simply provide a count variable that is the length of the params.messages. So how many messages do we currently have? And we will then go ahead and check for this message. Maybe we can print the messages first, or the messages count. So for example, print ln, and we print the count of the messages that we currently have. And then we can go ahead and check the count. So if the count is more or equal to, say, 10 or 20, let's do 10 so that we can check it. If it's equal to 10, then we're going to go ahead and clear up the messages params and leave the last 2 messages or last 4, however you want. So for example, we can go ahead and redefine the params.messages and redefine it by the same params.messages, but we're going to slice these messages and keep the last few messages for keeping the LLM a little bit smarter in the same conversation, but limiting the context from overflowing. So count -4 to leave the last 4, and then we use this colon to slice this slice, obviously. And then we can print a statement, for example, print ln that we have maybe history cleared, right? Or refreshed, let's say. Just like that. So now that we have this, we can go ahead and check and run the program. So go run dot This way, now, if we have some questions to the LLM, it will understand those questions. So for example, tell a joke, it will tell a joke, and then I can tell it's just to, like, just the subject, just change the subject, and it will understand we're talking about jokes because it has the history. So for example, about boats, right? And it will tell me a joke about boats, just like that. Now, if we keep talking to the LLM, we will run into the length of the messages that we just defined in our application. So right now we're on 8 messages, and if I just keep asking for more, we will get into 10. As you can see here, history refreshed. So now the LLM just has the last 4 messages, so more. So it doesn't understand right now the topic that we're talking about. So let's say, what are we talking about? Just like that, and we can understand, or we can see if the model understands what we're talking about. So it says that we're just having some fun with both themed puns and jokes. So it understands that we're talking about boats right here, but it doesn't understand we're talking about jokes, or maybe it understood that from the joke, but you get the point. So it has right now the last 4 messages as the first messages in the new messages array. Okay, we can also clear the terminal like this, and then we can exit just like that. Actually, not this command. This will trigger a response from the LLM. This is the command that we use to do that. So okay, so we exited the program. Now what I want to do is add some line breakers. So for example, here we can add a new line so that, you know, we print let's say every message block in its own. And what we can do is also include some color so that we can have better visuals or better CLI program looks. So to do that, I'm going to use the Fateh library. It's basically github.com/Fateh. So I'm going to go ahead and import it right here, and we can go mode tidy. So github.com/Fateh/color. This is a library that provides you with a simple color or colors, strings that you can use and provide some color in your CLI. And we're going to go ahead and say go mode tidy to install this library. Okay, we go back. Now it should be installed just like that. And now we can use that library to provide some colors. So for example, here, instead of just printing the arrow, we can go ahead and take this out, and we can say color from fateh.color, and we can use the, let's say cyan string, all right, to provide a cyan color for this string. And we can also print a statement here, just like let's say a welcome statement for our chat model. And we can use color white string, for example. And the white string will have an printf. And then here we can say, for example, we're using the model that is this model, and the model is coming from the model key, just like that. Of course, we forgot this semicolon here. Okay. So after this, we can also maybe change the color of the response of the LLM. So instead of just printing the response in the same color as our response, we can print it here in a different color. So for example, we use color dots, let's say yellow string, and then we provide the output just like that. We can also do the same here for the count. So instead of just printing the count like that, we can go ahead and say color.magenta string, for example, and we provide the printf, and we say, for example, count equals to this digit, which is going to be the count, just like that. Simple stuff, just gimmicks, to be honest, but it makes the program looks better, which will then make you develop more or have fun developing the program. So go run dot, we can see now a simple message in white, or in this white string. It tells us the model that we're using for this chat application. And when we write a query, we can see that our text here in this color and the model text in this color, and we can have the count, simple things, but very powerful. So if you like this video, if you learned anything in this video, make sure that you hit the subscribe button, or hit the like button, and consider subscribing for more tutorials in the future. And if you need any, let's say anything from this tutorial, like the GitHub repository, or maybe you need some text-based tutorial or a blog, I just did a blog post about this tutorial. You can check it out in my portfolio. So just go there and you can find the the blog post, and everything I just said here in this tutorial will be in the blog post with the link to the repository of this code base, so you can check it out for yourself. Also, if you want to check out Temple, if you are a web developer and you want to develop some front-end, check out this tutorial. And if you use Telegram and you want to build some Telegram bots, I am actually building a very powerful platform to do just that. So consider signing up for the newsletter so you can get free early access for the platform. Thank you again for watching, and peace.